So you know the quadratic equation, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, this value is your discriminant. D, discriminant, is equal to b squared minus 4ac. And this value determines the number of solutions and the type of solutions. Let's just look at some examples. Hold on. So in the book, they have a table that they'd like you to memorize. But like I may have mentioned, I'm not good at memorizing things. So it's better to understand it from my point of view. So your discriminant is this value underneath the radical. Right? So we have 4 different possible scenarios. Right? In this case, let's look at this one first. This is a perfect square. Right? 36 is a perfect square. And when I have a perfect square underneath my radical, right, I lose the radical. Right? So this was really going to become 5 plus or minus 6 over 2. So when I have a perfect square for a discriminant, I'm going to have 2 solutions, plus or minus. And since I don't have a radical, these are going to be 2 rational solutions. So I have 2 solutions, and they're both rational. So they might say, like I said, I'm happy with 2 rational solutions, but they might write 2 real rational solutions in the back of the book because these are real numbers and they're rational. Opposed to over here, since it brings us right to this one, this would be still 2 solutions because it's plus or minus, but in this case, these are not going to be real, right? These are going to be imaginary, right? So in this case, because we have a negative under there, if D is equal to a negative value, right here D was equal to a perfect square. If D is equal to a negative value, we would have 2, they might call these complex or imaginary solutions. Some textbooks say that contain I, or complex solutions that contain I. But really what's going on here is you have 2 imaginary solutions. Anytime the number underneath the radical, which is called your discriminant, is negative, you're going to have 2 imaginary solutions. Anytime your discriminant is a perfect square underneath the radical, you're going to have 2 rational solutions. It's easier than memorizing it. For me, visualizing it's easier than memorizing it. Right? In this case, it's neither of these. It's not a perfect square and it's not negative. Right? We just have the square root of 11, and there is no square root of 11. Therefore, this is an irrational value, the square root of 11. So we're going to have 2 irrational solutions. And the book might throw in the word real here. And it's in the real number system. It's real and irrational. But irrational is enough for me. And in this last scenario, you have a discriminant of 0. Well, if you have a discriminant of 0, you're going to have 5 plus 0, 5 minus 0. So really, you're just going to have 1 solution, 1 rational solution. or depending on your textbook, some say two of the same solutions.
Professor?
If I can lose the radical, right, if it's 0 or a perfect square, well, then I know it's going to be a rational solution. These are the only two that have rational solutions. And if it has a rational solution, then I know it could be factored. Factorable. So you could always see if something is factorable by checking the discriminant. Right? If you do b squared minus 4ac and you get 0 or a perfect square, it's going to be factorable. So in this first example, if you have to state the discriminant and the number and type of solutions, this is our discriminant formula. So you know that A is 4, B is -2, and C is +3. You want your quadratic equation to be in standard form, which means it's set equal to 0. It means these are going to have to get changed. And then we just substitute the values into the formula. So D is equal to my B squared minus 4 times my A times my C. So I'm going to have 4. Is this minus 48? I think. So D is equal to -44. So that means my discriminant is negative. So I'm going to have two imaginary solutions. Or sometimes they call them complex containing I. Sometimes they say two imaginary solutions, or they say two solutions that are complex containing I, which I means it's imaginary. So in this next example, I want the equation to be in standard form. I'm going to transpose this, so it's going to be 3x squared plus 4x minus 2 equals 0. Now that it's in standard form, I know A is equal to 3, B is equal to 4, and C is equal to -2. I substitute those values into the equation. It's B squared minus 4 times my A times my C. So it's going to give me 16 minus, or rather plus, negative times negative, plus 12, plus 24, plus 24 gives me what, 40? And 40 is not a perfect square, it's not negative, and in the context of the quadratic formula, you're going to have a plus 40 underneath the radical sign. So that's an irrational value. There's no square root of 40. So I know in this case, I'm going to have two irrational solutions. And I also know that this cannot be factored. The one prior could not be factored. I would have to use either the quadratic formula or completing the square to solve those two. And then in this last example, again, I want the equation set equal to 0. So I'm going to have 2x squared plus 11x minus 6 equals 0. A is equal to 2, B is equal to 11, and C is equal to -6. So my discriminant is my B squared minus 4 times my A times my C. So D is equal to 11 times 11, I believe is 121, plus negative times negative is positive. 8 times 6 is 48. D is equal to 160. Whoa. It's equal to 169. Which is a perfect square. Right? And if I have 169 under the radical, I'm going to have two rational solutions. Which means if I saw this problem and I wasn't sure if it could be factored, it can be factored.